Hi viewers, welcome back to the audio series segment from Multimagics channel. Myself is Funny. So far in this audio series, we have discussed various things related to audio, like what are the basics of audio, what are samples, and how to write those samples into a file called raw file or raw data, and how to encode the raw data, and how with the help of AMR encoder, and how to capture and encode in parallel using callback mechanism using AMR encoder. So we have gone through all those details. Today's video is the fifth video in this particular series, and then we'll be discussing an interesting project called Capturing Audio Raw Data and Encoding using FFmpeg or AAC in real time. So this is similar to the previous video. Instead of AMR, here we'll be using AAC with the help of FFmpeg. So let's jump into today's content. First thing is we'll discuss about the agenda. So first we'll go through the prerequisites needed to build this project, and also we'll recap what happened in the last video quickly, and I will go through a few introduction what is about AAC, and also we'll go through the block diagrams, and finally we'll go through code flow, GitHub links, and upcoming projects. So let's start with the prerequisites. So in the prerequisite section, as you know, so far this audio series we are developing all the projects for the Windows platform, and the architecture is x86, and the development environment we are using is Microsoft Visual Studio 2010, and it also works in the late from the later versions also, I mean more than 2010. And the third party libs we needed for this particular project is Port Audio and FFmpeg. And as I mentioned in the other videos and also mentioned in the various times, this particular project is not built from the scratch. This project is already built by our mentors as a kind of project for their pre-startup company. We are using the same project for our own understanding and exploring and gaining more knowledge and depth, such that we can integrate this particular future or project into our actual Multimagics product. Okay, so you don't need to worry about the FFmpeg and port audio libs that are all these are already generated and placed onto the GitHub. So I will share those links in the end of the video. So next we will start about the recap. So what happened in the last video? So we have captured the samples from the audio, and then we have encoded with the help of AMR encoder, and finally we have written that encoded data into the file. So the callback triggers whenever 160 samples are there. So this is about the AMR spec. So AMR spec per frame will be having 160 samples, and the 160 samples is we got with the help of this port audio framework. And once the samples are there, callback happens, and the callback will pass this data to the encoder, and encoder encodes and write the encoded data into the AMR. So this is happens until all the frames from the mic is captured, and then yeah, finally we write the data into the AMR file. So this is about the AMR conversion. See, now let's see, AMR is not only the audio codec which is available in the market. So we have a lot of other encoders or lot of other audio encoders available. Like for example, we have OGG, we have ACC, and we have MP3. So how do you want to convert, or how do you want to capture raw and encode it into the different audio codec formats? So we need to follow the similar process. So we need to process all the samples, and we need to call back parent samples. Here n is nothing but samples from frame, and that varies for each encoder. For example, we have seen 160 is for AMR, and 1024 is for AAC, and for MP3 they'll be having different frames, so different samples per frame. So we need to follow that specifications, and we need to call, call our callback and then encode that particular sample or particular frame, and then we need to write the encoded data into the file. So like that, we need to maintain a different headers, libraries, and study about the each APIs of the encoder. And then we need to finally convert or encode the data in the particular specific format you need it. So as you can see here, there's a lot of overhead is there. So you just to convert from one format to other format, you need to know the particular headers, particular libraries, particular APIs, particular specifications. A lot of things are coming into the picture. And in one application, to maintain all these different formats is tough. So it's like you need to, it's very overhead actually, to be frank. And also if you think about multi-platforms, it is really tough. So to overcome this problem, there is a way. So that is where FFmpeg framework comes into the picture. It is a very generic framework actually. And you can see here, so whatever data we are capturing, we are just passing the data to the FFmpeg framework. And FFmpeg framework underlying will just use these libraries and then convert that into the particular format. So in other ways, we can tell FFmpeg is an abstract layer to control what codec format you need. So just pass the codec name as argument, and there are certain sequence of APIs you need to call each time. And to support all these things, you need to build FFmpeg with the required codecs. Ease of use is the other advantage, and it's multi-platform. So these are the different advantages of the FFmpeg framework, and how FFmpeg framework will help us in better maintaining and better ease of use in the converting raw data into different encoded data. So you don't need to go through each encoder, study about the encoder, know the APIs. You just need to focus on study about the FFmpeg APIs, the particular sequence, how to call, or how to ready the encoder, how to call it. So you just need to focus on go through the list of FFmpeg APIs and just pass the encoder name, and rest of the things it will be taken care with FFmpeg framework. So you all need to focus on FFmpeg APIs. You don't need to focus underlying AAC, MP3, OGG APIs. You don't need. So we are removing this overhead now with the help of this FFmpeg framework. So in this particular video, we will just take an example on how to convert with the raw data into AAC encoded format. Okay. So this is what happening for the control view. As I mentioned, this is the application layer, and this is the where the application needs to talk to the different various libraries, various APIs, all those things. So a lot of overhead happens. But in this case, what happens? Application just talks to FFmpeg. All the APIs, all the calls only happens to FFmpeg. FFmpeg internally handles all those things. The framework itself handles which codec to call, what are the sequence that needs to call underlying this. So all these things are taken care of FFmpeg. All you need to know is identify the sequence of APIs that are needed for initialization, for processing and exiting from the FFmpeg point of view. That's all. So I hope I'm clear. So what is about FFmpeg? Those details already we have covered in the earlier video. So I just want to recollect that. So FFmpeg is the leading multimedia framework where you can able to decode, encode, transcode, mux, demux, stream. So a lot of operations you can do. So today we will be doing the encoding using FFmpeg. As FFmpeg supports different encoding formats, we will be specifically looking into the AAC encoder. And then FFmpeg framework, once you install these, all these libraries are shared libraries or static libraries available in both things. You need to be include this as a part of your project. Okay. And regarding the sequence of APIs, yeah. So we'll go through that in the code flow diagram. So currently we'll back to this current thing. Yeah. So this is about the FFmpeg and how it plays a significant role in ease of use and ease of maintenance when you are going for different codecs. And yeah. So now what is AAC actually? So we are talking about AAC. AAC stands for Advanced Audio Coding, and it is a specific audio codec. And AAC comes under the category of lossy compression or decompression. I mean, there will be a bit loss of data while you are compressing it, but that is like kind of not visible, not audible actually. Very less data is lost, and it is widely used as a default audio format across the different industries. A lot of platforms like iOS, Androids, desktops, or any basic multimedia applications, they use this AAC format. So this is a very famous encoding format for audio. It is popular due to because of its high quality compression and widespread compatibility. So for due to these reasons, this AAC became very popular. So now Specifications are very important for any encoder. So if you're not using those particular specifications, there will be a possible loss of data as you've seen in the AMR. So I'm just drawing a comparison here. So what is specifications for AMR and what are the specifications for AAC? For AAC, the sample rate we'll be using 44,100, which is a standard sample rate, and we'll be using channels too, like stereo, and samples per frame is 1024, sample per size is 2 bytes, and this is for port audio. While capturing, we are capturing it on 16-bit, and FFmpeg also will encode in that 16-bit format. So these are the specifications we need to take care before you start the capturing and encoding from AAC point of view. Okay, so I hope I am clear until this point. So the only thing you need to focus is how FFmpeg is used for users to use single APIs for different audio codec formats. Okay, so the sequence will be the same, just the codec name you vary, and rest of the things is taken care by the FFmpeg. Okay, so that we can see when we're going to the code flow. So before going into the much details of this particular AAC encoding, I want to give from the software point of view what is how many frames or how many bytes of data that callback mechanism will do or during the encoding. So here what happens is port audio captures the raw data, and we mentioned 1024 samples will be there. After 1024 samples, this entire buffer is passed to the callback and then it will be encoded. Okay, so why this particular number? So as we mentioned in this FFmpeg specs, it will sample for framer 1024. So it means so from channel 1 we'll be having first sample which is 2 bytes, and from the channel 2 we'll be having the first byte of the data, and like that for two channels we'll be having 1024 samples. So in total we'll be having 4096 of bytes. So samples per frame is 1024, and these samples is coming from channel 1 as well as channel 2, and then the total size of the each sample totaling into 4096 bytes. It means for every frame we will be processing 4096 bytes of data. So just want to give this interpretation so it will be easy when you're following the next of the slides. So okay, so here we have two channels. That's the reason we are having channel 1 sample 1, channel 2 sample 1, channel 1 sample 2, channel 2 sample 2, and again last 1024 sample of channel 1 and 1024 sample of channel 2. So like that it goes on. Okay, so this is the sequence for the AAC encoding. So things it is similar to AMR encoding only, but just with the help of FFmpeg we are doing it. And if you want to extend this same code or same functionality to other encoders, it is just very easy. In the code you just have to rename the encoder name. Like from AAC you can just mention MP3. But if you follow the previous approach like AMR encoding approach, you need to take build the MP3, you need to go and study about the MP3 APIs, all those things you need to do. So this is the particular sequence diagram for the AAC. So it's just the same. You open the stream, you register the callback, you start the stream, and after starting the stream, all the samples will be in the stream. And then once you start the stream, the callback function will be called triggered as per the port audio framework. And this callback function is now using all these FFmpeg libraries, FFmpeg APIs, and then encode the data. This particular samples or bytes of data, like 1024 samples or 4096 bytes of data into the encoded format. And the callback keeps on calling for each frame. Each frame will be having 1024 samples or 4096 bytes of data. After all the data is encoded, finally we terminate the port audio. So these are the typical port audio APIs we use, and this is the same callback mechanism we are using what we have discussed in the last video. Okay, so this is what happening virtually. So we have 1024 samples and all the data we are capturing, and each frame callback is called. and we are using FFmpeg or AAC libraries here, and then we are converting that data into the encoded data. The raw data we are converting into the encoded format of the type AAC. So like that, all the data is encoded into the AAC format. Okay. So the next thing is we'll go to the code flow. So actually, as I mentioned, this project is already done by our mentors. So I will just quickly go through this particular thing here. Yeah, let me. Yeah, yeah. So this particular project is already there in this code project, and yeah, this is about the introduction of this. So this explains the same thing whatever I have discussed so far. So I will straight away jump into the code flow. See, basically, first you need to open the stream. Before opening the stream, you need to initialize, you need to register this is for control C. So when to stop the capturing. Until that point, it keeps on capturing from the mic. So you need to initialize the port audio first, and you need to get the from which device you need to capture, in my case mic. And after that, what are in what specifications you need to capture, like type, number of channels, and then the all the other information you need to populate here. And then finally you open the stream, and then you're registering the callback function here. So this particular callback function is nothing but the AAC encoding code will be there inside this callback. We'll go through that. So finally here, if you at the end when there is no data, you need to terminate the port audio. Okay. So this is about the initialization thing of port audio. So next is you need to initialize the FFmpeg library things. So as you can see in the previous videos also, we need to take care of a lot of structures like AV codec, context AV codec, AV. So these are the two structures we need to maintain for the encoding the data into AAC with the help of port FFmpeg structures. So we need to initialize the FFmpeg like this, like AV register all, and then you need to. This is what I'm telling. So see, let's say if you want, you can use the same code. If you want to convert it into MP3, all you need to do is here you need to change the codec ID from AAC to MP3. That's all. So rest of, and maybe you need to change some metadata information. Apart from that, the rest of the code flow is still the same. Like I mean, for let's say for MP3 supports floating point. So the sample format instead of 16-bit, you need to give floating point. So like that, based upon few meta details, you need to modify, and the encoder name you have to give correct. So rest of the things it will be taken care by the FFmpeg framework. So I hope you are finding the powerful of the FFmpeg framework. So after initializing the FFmpeg things and then populating all the required details like bit rate, sample format, sample rate. So all those we have seen 44,100 is the sample rate and channels are 2 and all other details, whatever metadata, we are just populating it here. So once the codec is ready, so now the encoder is ready, FFmpeg is initialized, port audio is initialized, and we can start the process. So once you start the stream, so for each 1024 samples, you need to encode that raw data. Okay. So for that, you need to, you need to get the bytes. So this will be like 4096. And this all this data, you'll be sending it to this particular FFmpeg API called AV codec encode audio. And then we'll be getting the packet size, okay, the encoded data size. So that encoded data we are writing it is stored in this particular structure called encoder output. So this encoder output will be writing this into the file actually. If you can see here, f write data encoder output, this size, and then this size of the output. Okay, so like that, when the port audio stream starts, the callback triggers like that whatever I mentioned here. When the port audio stream starts, callback triggers, and the callback actually encode all the data with the help of the callback and writes that into the file. So as you see in the code here, the callback calls this particular function called audio encode, and then it takes the raw data of 1024 samples, and those samples you encode it, and then you write it to the file here. So this happens for each frame. Okay. So now after you press Ctrl C on the console application, the capturing stops. So once the capturing stops, you will close the audio stream of the port audio, and you will, which internally closes this port audio close stream, and also will be cleaning all the other FFmpeg allocations also. So all those details I have already updated the code to the GitHub, and you can download and you can go through the complete code. So I hope I'm clear on the code also. So now let's move back here. Okay. So this is about, yeah, so demo. So now let's run the demo actually. Uh, so this is the GitHub link. So this is the project I'm discussing about so far. So you can see here, this is the main function, and this is the output file, and these are about all the FFmpeg initializations, and these are all about the other memory allocations. And then here we have all the port audio initializations, and then in the callback you can see all the FFmpeg initializations, like here. Yeah, these are all the FFmpeg initializations. So all those things, whatever in the code project link I have discussed so far, it is the same code actually. Okay. So now let's build it. Okay. So now let's run the code. Okay. Started. Okay. I put the breakpoint. My bad. I will just disable all breakpoints. Continue. Okay. The capturing started. So that is the index we are printing. So whatever I am talking now, it is actually capturing. So we can play back that once the capturing is done. So the capturing is with the help of port audio framework, and encoding we are using is AAC encoder, and the APIs we are using to achieve that encoding is of the FFmpeg framework. We are not using any specific framework related to AAC. We are just using the FFmpeg APIs, the particular sequence we are following, and then we are passing the encoding name, all those things. Okay. So now let me stop the recording. Okay. Okay. The recording has been stopped. I press Ctrl C. So I'll just continue, and then the application has exited. So now let's go and check whether we can able to play back this. So this is where my actual output will be there. Yeah, the file stamp matches. So let's play. Okay.
Okay, the capturing started. So that is the index we are printing. So whatever I am talking about is actually capturing. So we can play back that once the capturing is done. So the capturing is with the help of port audio framework.
So I hope you are able to listen that audio. I'm not playing the complete thing. Okay, but
And
there will be some.
encoding we are following.
Yeah, I hope you are able to hear that playback. So this is where we capture the data from the mic and you encode it into AAC format with the help of FFmpeg framework. I hope I'm clear on all the topics today. So if you have any questions and queries, please do feel to contact us. As I mentioned, the current code, whatever I have shown is in this particular link. Go ahead and download it. It is available for the public. And the upcoming projects is about mixing PCMs. Here we'll be mixing two PCMs data. This is also called as audio mixing. And this will be a very interesting project called, there will be a streaming application. This is a streaming application where in a server we'll be having a set of audio files, and we'll be discussing about how a client can connect to server and exchange data, audio data, using certain protocols called RTP and RTSP. So all those details will be going through in this particular project. Okay. So until that point, we go through the previous videos and the current video, learn about all the audio basics, and have a good time. Take care. Thank you.